Let's try again. All right, so we know the basic shape of quadratics. I don't know what's happening. All right, let's see what happens. All right, so if this is a quadratic, the critical points on the graph are the two x-intercepts. So what is this? Oh, actually, I wish I'd drawn that separately. Oh, goodness sake. All right, I'm going to draw it differently so I can have different points. Whatever, I'm going to leave it. We're just going to deal with this. Oh, I'm still drawing it badly. I want to make it a bit more obvious what I'm doing. There we go. That'll be a bit better. All right, are we listening? Come on, guys, focus. All right, 2x-intercept. So what's this? The y-intercept. So the first thing we're going to try and note is the x-intercepts. Whoops, septs. Right, so 1 or 2. We also want to mark the y-intercept. We also want to mark the turning point. The turning point should be relatively self-explanatory. It's the point in which the graph turns back into the other direction, right? So it's going down, then at some point it starts to turn up again. So this is known as, sometimes it's called a stationary point or a turning point. It's the same thing. So it could be a stationary point. The other thing we want to do is the axis of symmetry. But guess what? You don't actually have to do anything because you've already got it by this point. The axis of symmetry is the turning point, right? So it's the mirror line of the graph. So these are the 4 things we want to mark on a quadratic graph. The x-intercepts, there might be 1 or 2, maybe there's none, but that's unlikely. The y-intercept, we're always going to have one of those. The turning point, there will always be one of those, or the axis of symmetry. The same is going to be true if this is a negative graph. We're going to have 2 x-intercepts, a y-intercept, a turning point, and an axis of symmetry. Okay? Now, this is why we need the skills we learned earlier this year to do this, because we've already done a lot of this stuff. We just haven't applied it to quadratic graphs. So I'm not actually going to teach you anything new. We're just going to apply stuff we already know to these graphs. So let's delete this and do an actual example. Okay, so if I have, y equals x squared minus x minus 6. So if I have this as my graph, remember there are 4 things we want to do. So x-intercepts, I'm going to do that over here. Y-intercept, that is extremely easy. The turning point is the bit that's actually going to be new. The rest of it is not. Okay, so let's work those things out. So to find, when you're doing linear graphs, it's exactly the same process. How do I find the x-intercept in a linear equation? Make y equal 0, right? That's exactly what. Whatever intercept you want, make the other letter equal 0. So we're going to say 0, equals x squared minus x minus 6. Now, I told you to go back and have a look at how to factorize quadratics. I put up links on Google Classroom, so hopefully if you didn't remember, you had a look at those. How do I factorize this quadratic? What do you think? I'm doing brackets, Helen. What have I got? Fantastic. Remember, I'm looking for 2 numbers that add to the middle. So this adds to -1 and it multiplies to the last. So it multiplies to -6. So for this statement to be true, for this to equal 0, anything times 0 is 0. Timothy, that is not a great use of your attention. Timothy. Focus. All right, so anything times 0 is 0. So that means one of these brackets has to equal 0. What does this x have to be for this bracket to equal 0? 3, right? Because 3 minus 3 is 0. What about this one? -2, because -2 plus 2 is 0. These are my two x-intercepts, 3 and -2. That's what they mean. We did say that earlier this year. It's all right if you forgot that. This one's much easier. To find the y-intercept, I just make x equal 0, right? So y equals 0 squared minus 0 minus 6. That bit's super easy. You just ignore the x's because they're all zeros now, and it's always the number on its own. So now we've got, so if I was going to draw this, let's draw a graph over here. What am I doing? Up here somewhere. All right. All right, so I'm going to mark the things I know so far. I know 1, 2, 3, 4, 5, 6, that the y-intercept is -6. The two x-intercepts are 3 and -2. What I don't know, oh, actually, I don't have enough room for this. That is so annoying. Sorry, I'm just going to have to draw it further because I need to go lower. Let's draw it up here. All right, so far I have -2, +3, and -6. The one thing that I don't know is the turning point. So this is the new bit. There's a tiny, easy formula. X equals -b over 2a. That is the little formula you need to know to find your turning point. So remember, any quadratic follows this form. This is how we did the quadratic formula. Remember that? So we said the number in front of x squared is a, the number in front of x is b, the number on its own is c. Same with the quadratic formula. That is what these letters mean as well. Same thing. So the x coordinate is -b. This is what? What's b? -1. So -1 is 1, right? And then, right, -1. So b is -1, right? The number in front of x is -1, but I need -b. So -1 is just 1. Then on the bottom of my fraction, I need 2 times a. The number in front of x squared is 1, so it's just 2 times 1. That means the coordinate of my turning point, why have all these lines disappeared? The coordinate of my turning point is where x is half. To find the y coordinate, I just put this back into the formula, right? So this is half squared minus half minus 6. So that's going to be 1/4 minus 1/2 minus 6. So what? That's -6 1/4. So that means the coordinate of the turning point is half and -6 1/4. Why a more of, oh, it's back. It came back. Yay. So that means this is my turning point. It's positive half and it's -6 1/4, which is roughly there. Does this look like it's going to do the right shape? What? I'm just a really bad drawer. It should, right? This should look exactly like a graph should. Hey, all right. So you can see that this is a smiley face graph. You are going to be using a grid, so it'll be more obvious. The only thing I have not marked is my axis of symmetry. The axis of symmetry is always the x coordinate of the turning point. So you don't have to do anything else. All you do is put a dotted line through the turning point. That is my axis of symmetry. Fancy word for mirror line, right? Where the reflection of the graph starts. All right, let's do another one of those so we can get the hang of it. Let's do a -1. Hurry up.